Question number 11 from motion in a straight line DPP. It states that a particle of mass m moves along x-axis as follows. It starts from rest at t is equal to 0 at x equal to 0 and comes to rest. So starting from rest and again coming to rest at x equal to 1, t equal to 1. No other information is available about this and what happens in the intermediate time from 0 to 1. Alpha denotes instantaneous acceleration of the particle. So as we know that it is starting at rest and also ending at rest, which implies it has to be an accelerated and decelerated motion combination. So I am going for v versus t graph here. Initially at t is equal to 0 seconds and also at x equal to 0 seconds, 0 meters, it is starting from rest, accelerates for a certain time and again decelerates for a certain time. Now see clearly, I am taking an assumption here. It is accelerating for half a second and decelerating for half a second. Means it has to have same amount of acceleration and deceleration. So one thing is sure, alpha cannot be always positive. Sometime it has to, for some time it has to accelerate, for some time it has to decelerate. Then only it can come to rest. Which implies option A will be definitely correct. About B, C and D, let us see some maths here. So let us assume it is accelerating for alpha, decelerating for alpha. Means this V max is going to be equal to, V is equal to U plus AT. So this will become alpha by 2. Right, for half a second it is accelerating. So area of this should become 1 because it is starting at x equal to 0 and ending at x equal to 1. So total area under V versus T graph should be 1. So half into base is 1 into height is alpha by 2 is equals to 1, which implies alpha is equals to 4. Alpha can be 4, right? So if you see option B, this cannot be correct because they are telling it cannot exceed 2. But according to my assumption, alpha can be 4. Now think something like this. Here I have taken equal amount of acceleration and equal amount of deceleration, so it will be half second, half second. Can alpha be greater than 4? Yes, it can be greater than 4. Then what will happen? This time will decrease and this time will increase. It will accelerate with a high amount of acceleration for a short time and decelerates for a longer time to come to rest. And alpha can be also less than 4. In this case, what will happen? It will accelerate with a small amount of acceleration for a longer time and breaks quickly and comes down to rest. So alpha can be 4, greater than 4 or less than 4. Some prediction can be done, and here they are telling in option D no prediction can be done with the given information. So D cannot be correct and C can be correct sometimes when it accelerates quickly and then decelerates slowly, something like this, right? So A and C should be correct options for this question. Thank you.